I want to look further at this thing called the quadratic formula. And let me just rewrite what it is. And it is the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And the part I want to look about is this thing inside the radical, this b squared minus 4ac. It is called the discriminant. And it has some, when it's equal to certain values, it tells us something about the quadratic equation. And so I want to look at a particular example to begin with. And I have 9x squared plus 6x plus 1. And I'm going to make that equal to 0. So a is 9, b is 6, and c is equal to 1. And what I'm going to do is I'm going to figure out the discriminant, and I have 6, and I'm going to square it, minus 4 times a times c. And well, 6 squared is 36, minus, well, if I take a look at here, 4 times 9 times 1 is 36. My discriminant is 0. All right? So let's just continue with this and see what happens here. Well, I'm going to put in, I'm going to have the opposite of b, so I'm going to have a negative 6 plus or minus, and I already figured this out. This is 0, right? This is this b squared minus 4ac I figured out to be 0, all over 2a, which is 2 times 9. So the square root of 0 is 0, and negative 6 plus 0 is a negative 6, and negative 6 minus 0 is a negative 6, so I'm simply left with a negative 6 over 2 times 9, which is 18. And this simplifies to a negative 1/3. And so if you think about this, sometimes they call this a double root, because I have a negative 6 plus 0 over 18, and I have a negative 6 minus 0 over 18. And in both cases, I'm going to get a negative 1/3. Well, what is a negative 1/3? A negative 1/3 is really this negative b over 2a, which happens to be our line of symmetry and our x-coordinate for our vertex. So in this particular case, we have a graph that is simply touching the x-axis at a negative 1/3, and I'm touching it right here, and I'm going up. So we say we have one root. And what type of root, or one solution? We have one rational solution. And remember the words root or 0 or x-intercept mean the same thing. So when your discriminant equals 0, when this b squared minus 4ac equals 0, it means what you have is only one solution, and it's a rational solution. All right, let's take a look at another one. Again, I'm going to write at the top the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, I'm going to have 9 x squared plus 6x plus, and this time I'm going to have, let's go with 5. Make that equal to 0, and let's see what happens. So again, a is 9, b is 6, c is 5. So I'm going to look at my discriminant, and I'm going to have 6 squared. Remember, my discriminant is b squared minus 4ac, so I got 6 squared minus 4 times 9 times 5. Well, this will be 36 minus 4 times 9 is 36 times 5 is, I believe, 180. And so in this case, I get a negative 144. Well, what does that mean? That means inside this square root, I have a negative 144. And we know about I, and we can say that this is equivalent to 12i. Well, it means we have no real solutions. What we have are two imaginary solutions. And if I would continue on, I would have the opposite of b plus or minus. I already told you where the 12i came from. 12i over 2 times 9. I think we did that before. We'll get 18. And so this can be simplified down. I think I can divide all those by 6. So I have a negative 1 plus or minus 2i over 3. So here's my two imaginary solutions. A negative 1 plus 2i over 3 and a negative 1 minus 2i over 3. Okay? No real solutions. In other words, my parabola in this case is above the x-axis. My vertex is above and the graph is going up, and so it's not touching. I do have two imaginary solutions, but no real solutions. Why don't I have real solutions? Because the graph is not touching the x-axis. All right, let's take a look at one more, and then I'll summarize. Again, I'm going to write the quadratic formula. The more you see it, hopefully the better you'll be able to remember it. B squared minus 4ac all over 2a. And I'm looking at this thing called the discriminant, which is b squared minus 4ac. That's the discriminant. Put that in little brackets right there. And the problem I'm going to have is, I'm going to have 2x squared plus 13x plus 5. All right. So A is 2, B is 13, C is 5. And I have my discriminant is going to be 13 squared minus 4 times 2 times 5. And I have, this is 169 minus 40. And I get 129. Okay, so in this case, I'm going to have the opposite of b, which is a negative 13 plus or minus the square root of 129 all over 4. 2 times 2. Which means I have two roots. And I have one over here. So in this case, when my b squared minus 4ac was greater than 0, when it was positive, I had two real roots. And what do I mean by that? I mean solutions, x-intercepts, I mean zeros. They all mean the same thing, all of these. Alright, so I am going to summarize what you need to know. First of all, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We have this thing called the discriminant. It is b squared minus 4ac. When b squared minus 4ac is less than 0, it means I have a parabola that in some fashion is not touching the x-axis. I have no real solutions. I have 2 imaginary solutions. Okay. When b squared minus 4ac equals 0, it means my parabola is touching the axis at one spot. In other words, the vertex is touching the x-axis. And so I have one rational solution. It's a real solution. It's rational. Okay? Because I'm touching at one place. And if b squared minus 4ac is greater than 0, it means I have a parabola that crosses at 2 places. So I have 2 real, they could be irrational, they could be irrational, 2 real solutions because it crosses at 2 places.